Evening, everybody. This is Alex. I'm here for Adam tonight. Adam is celebrating his 10th, I think, wedding anniversary. So he made the smart decision, and he's not going to be with us tonight. Tonight we're going to have me talk a little bit about the upcoming eclipse. It's going to be an overview of eclipse planning and how to watch an eclipse and some things to take into account, what to see during the eclipse. It's not for those astroimaging people we have out there, and we should have a bunch because that's what the whole show is about. It's not about taking pictures during the eclipse, because there's a philosophy that you kind of, during your first eclipse, you don't take too many pictures. And because we are going to have some people with more experience taking eclipse pictures coming on to show us how to take eclipse pictures as the year rolls on here. We're going to start this evening talking with Josh. Josh, can you tell us a little bit about the images of the week?
Yep, thanks, Alex. So first I'm going to share some details from Nicholas Kazillian, who shared this awesome wide field of the North American Pelican Nebula, and it has a little bit of a hard time actually getting on the show just because of where he lives, and so he won't be joining us, but he did share some details with us. He used a William Optics Zenith Star 66 refractor with the William Optics Flatner 6 reducer corrector. He's actually using a Moravian G2 8300 CCD, and he used HA03 and S2 Astrodome filters on a ASIQ6 Go2 Skywatcher mount, and he's using the QHY5L2 color on the finder scope. Let's see, he said the acquisition has been made using Sequence Generator Pro, and the processing was done with PixInsight for pre-processing and some processing, and then Photoshop was used for color adjustment. The HA channel has been done last year during his holidays, and the O3 and S2 channels have been done this year. And again, it's really great image, and we appreciate Nicholas sharing that. He has a couple other really great images that he shared as well on Facebook, so definitely check them out. Lots of great details and beautiful colors. And then the other thing that we're going to announce is Carlos David's Bro wide field image. So Carlos, we don't have a lot of details on this image. If you'd like to join us and talk about the image next week, or just drop us a note either on Facebook or Google+, love to have you on, or just love to hear more about this image. But definitely deep and lots of beautiful colors in that one. So thank you, Alex. Alex, I think you muted yourself.
I muted myself while you were talking. And
there you are.
I'm not Adam. Adam does this seamlessly. Don't you wish I was as smart as Adam? Do you see my screen for the PowerPoint?
You are up and running, looking good.
Okay. 380 and counting. I must have done something wrong here. I actually gave this presentation last Sunday, and it was 380 and counting. Now it's 372 or something and counting. That signifies the number of days left before the eclipse. I did this presentation up at Sequoia National Park during their Dark Sky Festival, and it was fairly well received. There are a number of people there that had never seen an eclipse, and they didn't realize some of the things that you have to look for during an eclipse, and that's what I'm here to talk about today. I took some of the pictures here. Alison Wong and Bob Stevens, two eclipse chasers in the Riverside Astronomical Society, two of my friends. They've taken more of the pictures. You could tell which ones Alison took and which ones Bob took, because they were the really good ones. The ones I took are all over the place. We didn't actually note which person took which picture, because the original, most of these pictures were taken from the Egypt eclipse back in 2006, and frankly we've forgotten who took which of the pictures. We could probably figure it out, but it was too much work, so they're unattributed. The good ones are Alison's and Bob's, and I've got some in there too. Let's talk about the eclipse. The eclipse is a crazy thing because there's a lot of anticipation. There's just so much to get ready for. There's so much to think about. The fact that our ancestors, you know, 4,000 years ago or something like that, could predict when eclipses were coming is kind of an amazing thing. And it was a scientific thing back there, as well as a little bit of a threatening thing to them all. We'll talk about it. But let's talk about the science involved in the eclipse here, first of all. 1.75 arc seconds is proved Einstein's theory that a star behind the sun could be sending out light, and that light would be bent, and we could see it. 1.75 arc seconds, and remember there are 1,286,000 arc seconds in a circle. So that's a very small amount. Light bends, and when Eddington found that out, he proved during the 1919 solar eclipse, he proved Einstein's theory, made Einstein a famous man. Einstein was happy. Of course, he knew it would happen, but he was happy that this actually happened. It was a great anticipation because they had the theory. They knew that they could probably do this, but they couldn't prove it until they saw that solar eclipse. Well, science is still going on. For instance, take a look at this picture up here. This is a picture of the 2006 solar eclipse out of Solum, Egypt, and I superimposed it on top of a Soho picture of the same day, and you can see how the inner corona stretches out into the outer corona. The outer corona is visible from the Soho picture. The inner corona is visible, but this inner corona is only visible during a solar eclipse on the Earth. The reason is because in order to protect the instruments in Soho, they have to have a blocking out disc, and a occulting disc that blocks out essentially the center of the solar disk. How do you go about getting a picture of the solar disk and see how it changes? If those of you have seen Soho movies, you can actually see the motion in the corona. Well, you can't see that when somebody's watching an eclipse. You can't see the motion because you can't watch it for longer than maybe 8 minutes is the longest total solar eclipse you're going to see. But what if you could follow the corona all across a total eclipse from one end of America to the other, maybe about 2 hours that it takes? Well, that's what the Citizen Kate experiment is going to be doing. They're going to be in Oregon, and they're going to be over in Carolinas, and they're going to be taking pictures all the way along the solar eclipse. And when they get and put all those pictures together, they'll actually have a movie for the first time of the total solar eclipse's inner corona, something you can only see during a solar eclipse, that inner corona. So that's one way that science is going to be doing things. But science has always been involved in this kind of stuff. Look at this is some of the things. You can read it on your own screen. The study of the solar corona gives us much information about the sun's surface and its global variations. The morphology of the corona is changing due to the reorganization of the surface magnetic field during the solar cycle, which can be seen in eclipse pictures taken at different epochs. Yeah, right. Okay. There is scientific anticipation. That's really important, but that's not why I've called you here together. I want to get you excited about going to see the eclipse. I know most of the people watching here already are going to watch the eclipse, but it is a spectacular thing. It can be predicted centuries in advance. Once upon a time, back by the Babylonian times, there was heavenly vengeance involved. Kings lopped off people's heads because they got predictions wrong, or because the sun disappeared without them knowing it was going to happen, or because they lost a battle because they didn't know that the sun was going to eclipse. They didn't go to battle. There was heavenly vengeance involved. But this is actually what it's like nowadays. Oh, I forgot. You can't get sound off this, can you? Josh, you out there? Can you hear the soundtrack?
No, you can't get sound off of it.
Dang. Well, let me imitate for you what this soundtrack is about. Ah, I'm so excited. Oh, look at the sun. Oh, look at, oh, wow, yeah. Oh, look at it. Actually, you can probably hear it. Is that doing it?
It's just very quiet.
someday we are going to have to figure out how to get sound on these presentations, because a big part of that was listening to the excitement in the people as they get all excited about how the eclipse is coming and how the sun is disappearing back there.
We heard your excitement.
We heard my excitement? Okay. There's a lot of that silliness going on. Okay. How an eclipse works, I think most of the guys that are watching today, most of the ladies and gentlemen that are watching today already know about this. I got to get this moving. Oh, I get this great big sound in the back of my head that you guys aren't getting. But the moon's going around, and every once in a while it casts a shadow across the earth. But the moon is not just going around. It's going up and down across the plane. And it's only when that shadow happens to hit the earth that the shadow actually crosses the earth. And that's when it's happening. So there are a number of cycles. It's going up above the plane of the earth, down below the plane of the earth, across the plane of the ecliptic. Sometimes it's between the sun and the earth, and sometimes it's on the other side. And sometimes it goes into a lunar eclipse. So I think you guys know that, so I'm going to skip through that part. It was more important last week. There are several types of of eclipses. There's lunar eclipses and solar eclipses. Lunar eclipses mean the moon is behind the earth and is in its shadow. And solar eclipses means that the moon's in front of the earth, between it and the sun, and that it casts a shadow. But look at the different shapes of the shadows. There is a large shadow that the moon has to pass through. And wherever you are along this side of the earth, you can probably see the moon. However, the shadow cast by the moon on the earth is a much smaller shadow, and in order to see it, you have to be in a very specific place. Some of the things that are not generally known is that there's actually more solar eclipses than there are lunar eclipses. It's just that you can't see them from very far away. You can see this one from any place on this side of the earth. This one, you've got to be right there. So you tend to think that there are more lunar eclipses, and we certainly see a lot more lunar eclipses than we see solar. There were about 240 solar eclipses last century, about 150 lunar. But it takes about 375 years before a solar eclipse will come back to the same point on the earth. A lunar eclipse, only about 2.5 years. So we get to see, from any given point on Earth, a lunar eclipse about every 2.5 years, and a solar eclipse much, much, much more often. There are some confusions. Partial eclipses, total eclipses, and annular eclipses. And the three differences here relate to partial eclipse, means that the moon did not actually cross the center of the sun. And because it didn't, it only ate a little part of the sun. It ate a little part on the side. And then it moved on, and it didn't get to be a total eclipse. But annular, hybrid, and total, those three types of eclipses are all called central eclipses, where the moon crosses the center of the sun. This is a total solar eclipse. And you can see that all but the corona, the outer atmosphere of the sun, is exposed. This is a picture, and this is a picture of a hybrid, or of a annular eclipse. You can see the annulus, or the ring, around the sun. The difference is that the size of the moon varies by about 14%, depending on whether it is high above the earth, down here, in the lower left-hand corner. If it's high above the earth, it's further away by about 14%, and therefore 14% smaller, and it can't quite cover the disk of the sun. A hybrid eclipse, that's one where it starts off as an annular eclipse, and then because of the geometry, manages to cover the sun for just a little bit, and then it becomes annular again towards the end, depending on the peculiar geometry that covers. It's only in a total eclipse that you can see the corona. In an annular eclipse, you can't see the corona. This eclipse that we're talking about for August 21st of 2017 is going to be a total central eclipse. All the cycles that we're talking about, when we saw this spinning around up here, all of those cycles, when you add them together, the up above the plane of the ecliptic, below from apogee to perigee, coming around between the sun and us and on the far side of the sun, when you add them all together, and they each have their own names: synodic, tropical, anomalistic, draconic, and sidereal. They each have their own name. They make cycles, and when you put all those cycles together, it turns out that every 18 years or so, every 18 years ago, all of those repeat. An anomalistic month, where it goes from perigee back to perigee again, is 27.554 days long. A sidereal doesn't really matter to us, but a tropical is 27.321 days long. When you have 239 of them and 241 of those, you wind up with 6,585.3 days. And the same for the other types of months that you can get into. So it turns out that every 6,585 days, everything repeats. And when it repeats, the images will be, the sun will be in approximately the same place it was before. Now there's a little bit of a difference. Here you see 1937, and 18 years later, 1955, you'll see they've got the same pattern, but they're shifted 1/3 of the way around the Earth. And that 1/3 of the day is because the draconic and the synodic months are about an hour apart, and that shift allows the Earth to turn 8 more hours. Another 18 years, another 18 years, another 18 years, and they repeat themselves. They repeat themselves over and over for about 1,300 years, and that's the Saros. And so right now we're going to be in Saros 145. That's the eclipse that's coming in August 21st. We'll be in Saros 145. And this is its path that it's taken through the years, through about 1,400 years it takes to get from the North Pole to the South Pole. Other Saroses go from the South Pole to the North Pole and things like that. This is where the moon shadows are going to actually be that day, August 21st. You see it starts up here in Oregon and heads across the continent. You can get a good copy of this by going to the NASA website, Total Solar Eclipse, and it'll give you all the technical detail. But it's more fun to Google these things. Just Google Total Solar Eclipse, and you can find all sorts of maps like this, where it shows that in the course of 2.5 hours, it's going to go all the way across the United States and then head off into the Atlantic Ocean. What do you actually do on an eclipse day? Now, this is for all the people who've never actually been to an eclipse, and this is from Hopkinsville, I think, Kentucky or something. Yeah, Hopkinsville, Kentucky. You start off early in the morning. You get there 4 or 5 hours before totality, at least 4 or 5 hours. You should have spent the night there before if you can. You arrange for your creature comforts. You decide, while the morning's happening here, you decide where you're going to be and what you're going to be doing. And then the contacts start to happen. The first contact is when the moon first takes a little bit of a bite out of the sun. From first contact to second contact, and here's what first contact looks like right about there. See it? You just got that little bit. Now for an hour and 20 minutes, and in this case, if you're in Hopkinsville, you're going to be, what time of the day is it? 12:05. So you got there at 5 o'clock in the morning, 7 o'clock in the morning, and now it's 12:05 or so, and you can see that the sun's starting to take a little bite out. You got about an hour and 20, usually, in this one I think you got about an hour and 20, and it goes up to 2 hours and 10 minutes for this process of the moon biting the whole sun. Okay? That's first contact. Second contact is when the moon comes and completely covers the sun. So we're right now after first contact. We're in the partial phases. This is the phases where you're just scoofing around, doing goofy things. And right about in here, where you get close to second contact, and I'm going to stop that. See, we're getting close to second contact, which is the point at which the moon completely covers the sun. During this time, right where you get this big, where you get this thin streak across here, weird things start to happen with the light. Up until now, you really couldn't see anything funny happening with the light, but weird things start to happen. Shadows start to get sharp. You can start to have a pinhole effect through the leaves of the trees, and you can see actually, whoops, where did I go? Where did I go? Back up to here. Okay, so we're down to about here. And then finally, you get to second contact, boom, everything gets dark. There's some things I'll tell you about what happens. This lasts about 2 to 2 minutes and 40 seconds. And then finally you get third contact. Third contact is the point at which the moon no longer covers the sun. You've got another hour and 20 minutes to 2 hours and 10 minutes, depending on where you are and what eclipse this is, to see the final part. And then the day just kind of wears on. Do we have any questions yet? Somebody handling the questions part?
I'm in the chat room. I don't see any in the chat room. As far as Q&A, I don't see any in the Q&A. The only one that I saw was, do we know if the ISS will be taking video of the moving shadow across the Earth's surface?
I do not know that. We did have a post on our Google Plus website that said that one of our members is going to be up in a, I don't know if he's going to be up in the balloon or he's going to have a balloon up there 100,000 feet trying to take a picture of the moving shadow. So I have seen a picture of the moving shadow for the Egyptian eclipse taken from the ISS, but I don't know if the ISS will be making a pass right about that time or not. Okay?
Thanks.
Let's get back to some definition of terms and some things to look for. You've got to pick your place. All right? We're going to be talking about some of the considerations in picking your place. If you haven't picked a place yet, a lot of people are saying, oh, if you haven't picked a place yet, man, you're out of luck. I tend to disagree very highly with that. I think it's nice if you've picked a place and if you've got a reservation and you know where you're going to be, great. But if you don't, you can fake this pretty well. We've got a good transportation system, and you're okay as long as you're fairly close to the line of totality. But there are some definitions of some things and some interesting topics that we need to talk about here. The first is you got to pick a place on the center line. You can see from this chart here that the eclipse actually stretches from way out in the Pacific Ocean here and way down to South America, all the way up past the poles, okay, past the North Pole. So at some point here, you will be in well, I don't know if it goes past the North Pole, but it's up there. You will be in the totality, or you'll be in the partial eclipse. But honest, you get nothing unless you're in this particular line, this small blue stripe. And frankly, as you're going to see in a little bit, you've really wasted a lot of time if you haven't gotten directly center of that line. This is where that line goes through, and this is the degrees of totality, as you can see across here. But this is not much. I mean, you can see an eclipse like this, a partial eclipse, several times a year. You can see some kind of partial eclipse. It's only the total eclipses, though, that you're paying the big money to go see. If anybody says, yeah, I'm only going to be 100 miles away, so I should get a pretty good eclipse. Yeah, well, pretty good is nothing. All right? Yeah, you're either going to get it or you're not. You either get totality or you don't get totality. Let's take an example. Here are 3 maps. And by the way, you can Google these maps. Again, Google 2017 solar eclipse and go for the interactive map links. And here are 3 places I picked out, all in the Ozarks someplace. And you can see, and I think these are detailed enough for you looking at home to see what they actually tell you. They tell you what time the partial eclipse is going to start, what time the total eclipse is going to start, when it's going to be in maximum, when the end of the total eclipse, and when to the end of the partial eclipse. And it's going to tell you the azimuth and the altitude, so generally what you're going to look like. All 3 of these places get 100% coverage, but St. Clair, which is right here on the center line, gets 2 minutes and 40 seconds. And a mere, I think it's about 35, 40 miles away down in St. James, Missouri, you're only going to get about 18.2 seconds. On the other hand, the difference between there and there It's not linear. As you get closer, it rapidly increases. So any place from here to here, any place, 10 miles either side of the line, you still get a pretty substantial chunk of the total possible time, 2 minutes and 16 seconds, if you're midway between those two places. Okay, Sullivan, for instance, is midway between the two, and you still get 2 minutes and 16 seconds. So St. James, St. Clair is up under here, Sullivan is right there. You can see that you get pretty good, but don't get down near the far edge. Okay, don't be down near the edges. Be on the center line if you can at all help it. Okay, it matters. Don't let anybody think you can't. On the other hand, does it matter whether you see it in Oregon or in Carolinas? No, it doesn't matter much. If you're in McConahay, Illinois, which is the line of the greatest duration, it's going to be 2 minutes and 40.2 seconds. But if you're in Lime, Oregon, it's still going to be 2 minutes and 9.6 seconds. So you can still get a pretty good share of your total time. You don't have to travel to Illinois and see Eric. You can just stay in Oregon if that's where you are. You don't have to put in that extra 2,000-mile trip. East-west doesn't matter nearly as much as north-south along the eclipse line. Pay attention to what time of day it is and the altitude of where the sun's going to be. Look, this thing's happening from 9 o'clock in the morning to 1:17 p.m. depending on where you are. And the sun's going to be high in the sky, generally speaking. It's not going to be low in the sky. And where is it going to be in the sky? In Wyoming, here at the Grand Tetons, it's going to be kind of up at 45 degrees and to the east of you. All right? So if you anticipate getting the Grand Tetons in the background of your picture of an eclipsed sun, you're not going to do that because the view of the Grand Tetons are to the west. You're looking to the west when you see that magnificent view of Jackson Hole and the Grand Tetons. And the sun it's 10:16 in the morning. The sun's going to be in the east. So pay attention to that. This says a lot for how much you have to worry about for this particular picture. What is this? This is a movie up here of some kind. Oh, that's Hopkinsville. Okay, so watch where the sun is going in this picture, and you'll see that during eclipse, it's way up in the sky. So this is not going to be a great time to be taking pictures of the scenery with an eclipsed sun at the same time. You're going to be looking up in the sky to see the sun, not low on the horizon. So take that into effect. Also, your atmospheric seeing in the morning here in Oregon, you're going to be looking fairly low. All right? By the time you get to eastern Oregon, you're looking pretty much up in the air. So it's not that big a deal. You're not looking through as much atmosphere to get to see the sun. So take that into account when you're looking to see where the sun is. See, you can see that the sun is high in the sky here in Hopkinsville during this eclipse, and during totality, it's way up there. Okay? So that's one of the things you got to consider. But the most important thing to me is considering what the weather's going to be, because it doesn't matter all the other plans you've made if you've made plans to put you where the thing's going to be in clouds. And generally speaking, the eastern part of our country is more likely to suffer clouds. They've got 70, 75, 85% chances of clouds in through here, and the best place in general is right through here. Here's a more detailed view of it a little bit. This is probably the place you want to be if you're considering only the clouds. Travel time might be different, but here you're looking at 35, 40% chance of clouds, whereas here you're looking at 80% chance of clouds over in the Blue Ridge Mountains. So pay attention to this kind of thing. Of course, we can't all just take a vacation and drive off to wherever we want, but seriously, this blue area in here is generally where you're going to want to be if you want to make sure that you don't have to chase the clouds. If you're going to go to Oregon, you better avoid this coast. Get on the other side of the Cascade Mountains here. And most importantly, keep up to date, because these are long-range records. They count meteorology for many years, and they average things out. It says nothing about what it's actually going to be today or tomorrow or the day of the eclipse. So while you can make your best shot and make your best bets according to where these blue spots are along here, you don't want to rely on that solely. You better keep your weather goggles on and make sure you pay attention to that. Another thing you want to think about, you got to think about your transportation. You want movement options. You want to be aware that there's going to be some unusual traffic that day. Probably not as drastic as everybody says, but there will be some unusual traffic that day at some of the places that you really want to go. I would imagine that the Grand Tetons are going to be fairly full because everybody's talking about going to Grand Tetons because it's one of the most beautiful places in the world. Hey, it is, but it's going to be just as beautiful the next day and the day after, and you're not really going to see much different there just because there's a solar eclipse going on, except that there'll be 8,000 more people there, which can be kind of annoying. Let's take a look at this. This is a blown-up version of what you saw earlier. This is the one edge of the totality. Here's the other edge of the totality. And this is where the totality, the line of totality goes. I want you to pay attention to, if you were in Hopkinsville or you're in Princeton, look at this beautiful road that gets you from here to there. What if there's a cloud in Princeton? You can jump on this road and head down this way. Or you can jump on Interstate 24, which you know you'll be able to travel at 45, 50 miles an hour, and find a different place. Pay attention to that. When you are picking out your place to go to the eclipse, you find yourself a road that heads east-west along the eclipse line, so that if there is a cloud where you are, you wound up in Carbondale so that you can see the greatest duration of the eclipse, and Carbondale happens to have a big puffy thundercloud over it, and you got to zip someplace, well, you want to be able to know where you're going to go along that east-west line to get away from that particular cloud. So have a transportation plan. Check out what unusual traffic you've got. Check your movement options. And east-west traffic is more important. It doesn't do you any good to zip up and down this line, as we talked about earlier, because as you're zipping up and down that line, you're rapidly losing time of totality. So think that one out. Get your site accommodations made up. This is us, this is my lovely wife Judy, who will be celebrating her 40th anniversary to wedding to me on that particular day, August 21st, 2017. That's Judy down there. And that's Richard, and there's some other guys from our club and various places. We parked our RVs like this, and I got up on my RV and we took a picture. I want you to notice about some things here. Obviously, parking's not a problem in the middle of this farmer's field. Mobility, there was a road running right down along here that ran east-west, just like we said. Crowd control, you can't tell maybe, but you notice how these are lined up in a line? Well, they're all lined up pointing obviously towards the sun, except for this silly thing here. They're up pointing towards the sun, and you notice how we kept this line clear. One of the problems you've got with crowd control is that you'll set up, and somebody else will want to come and set up right in front of you. Well, I'm sorry, there's going to be lots of people there, so that might be a problem. But be aware that nothing is sacred on these things. You should show respect for others, and you not find, hey, there's a good place to observe. I think I'll set up in front of that guy. Don't do that. That's annoying. It's obnoxious. Don't do that. That's one of the things that I've seen happen at eclipses many times. By the way, I suppose I should say, I've been to, I think, 4 or 5 central eclipses. Got rained out on one, and that's about it. I'm not a real eclipse chaser like some of the guys. Overnight accommodations. It would be nice. I want to remind you guys that this is a new moon weekend. It may not have sounded obvious to you. You're so excited about the solar eclipse, you don't realize that it's also a great opportunity to be observing. If you're out in the west someplace and you're away from clouds and stuff like that, and you're in a dark sky site, it's a new moon night. So take your big dogs with you as well as everything else you're going to be taking. You're going to, just being on the side of the road in a parking lot is probably sufficient for everything you want to do. You may not have a big RV to set up. it would be nice to be close to the viewing site. It's best to be at the viewing site, particularly if you want to polar align your scopes and make sure that everything is working long before anything can start up. Also consider what time of day this is going to be happening for you. For some of us, it'll be happening at 9 o'clock in the morning. For others of us, it won't be till 2 o'clock in the afternoon. There's a lot of boredom involved in these things while you're waiting. Well, not really boredom, but you're waiting for a while for everything to happen. So pick some place that's nice. I told you earlier that or maybe I told the guys before we started broadcasting, I'm not as worried as some people are about making sure they've got a reservation in the hotel right in the path of totality. I think that because of the time of day this is happening, anybody can see the eclipse by getting up early enough, driving over to wherever their preferred observing site is, and if they had to sleep in the Walmart parking lot the night before, hey, they can still see the eclipse pretty easily. Other people may differ on that. They want everything done just right, and they want to have their hotel right under the observing site, and good luck to you. I don't think you're going to find a reservation if you haven't got one already. What kind of equipment you need? Well, to see the solar eclipse, you should be comfortable. You need shade, stool, a chair. So we got our RVs back here, my pickup truck, and my trailer was back there with its awning out and everything else like that. This is the rig I was watching the partials with. Actually, this was an annular eclipse. This was the transit of Venus. I was in Greece for this, and because I was in Greece, I did not want to carry anything that would be taxing. When I travel, I generally travel with just carry-on baggage, and so I just took a Teleview Ranger and some other fancy, flip mirror here so that I could watch both. That's what I did for that. When I had my RV, I could afford to take a little bit more, so I had my GM8 with, that's a Lunt Hydrogen Alpha. This is a Bader Solar Astrofit, and this is one of those sun scopes. You see the partially eclipsed sun right there next to my face. Okay? For totality, all you need is your naked eye. It's nice to have a driven mount for the partial phases, and if you're taking pictures during the totality, it's nice to have a driven mount to know that it's still pointing right at the sun where it's supposed to be doing. If you're going to be taking binoculars, it's nice to have a binocular mount, but there will be times when you want to be able to take them off the binocular mount, take the binoculars off the mount, and swing them around and look at all the weird things happening around you. Your telescope needs half to 1 degree if all you want to do is look at the partial phases. All right, and so that's what a telescope can do that pretty easily. But if you want to take pictures, or if you want to look through your telescope at totality, you need 3 to 5 degrees total field of view. Think that out. A lot of people say, oh, what kind of scope do I need for that? You don't need any scope for a solar eclipse. If you're taking a scope, be sure you've got one with enough field of view that you're going to be able to get the whole sun in. And while you normally think of a sun as half a degree, well, and that's true, it's half a degree during the partial phases, but during totality it stretches out to 3 to 5 degrees. So be aware of that. It's something you might not have thought about. The partial phases, you need to have filtering. Even the late partial phases, with just a few seconds left to go before it goes total, you need to have any one of a number of options for for looking at the sun. You'll blind yourself if you don't. These are available now. I'd suggest you get them now rather than wait. They may be out of stock at certain points. I know for the annular eclipse across the Southwest about 3 years ago, they did run out and you couldn't get any eclipse glasses. Same thing with Thousand Oaks optical filters. Full aperture solar filters come in a variety of colors and effectiveness. Do you need a hydrogen alpha scope? No, only if you want to see in hydrogen alpha. The prominence is you can see in hydrogen alpha during partial phases. And the problem is that if you want to look at the sun during totality, you're not going to see anything because the sun's going to be hidden. There's not enough light coming off of it. So your solar scope, like the PST or the Lunt filtered scopes, won't do you much good. These are cool, the sun spotters. They're just projection. The light comes in, bounces, 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 and projected down here. And you can watch little bits of it getting eaten up. Here's my sun scope. You saw that in one of my pictures up there. And this is what it looks like on a portable. You can actually see the picture of the sun. This is just projection material stretched across a funnel. You can get at the auto parts store with an eyepiece down here. And you just have the telescope, you know, show it. This is extremely popular for folks. When you saw, where was it? Here, everybody during this wanted to put their face up there and took a selfie, and so that you could see the partially eclipsed sun and their little face, and that was cool. This is a method that some people advocate. It's called projection photography. Light comes down, bounces up, bounces out. It bounces out here. The problem with it is it's got to be constantly adjusted. All these, this has to be adjusted to that. And somebody could say, oh, could I look through here? And they can actually step in there and look through that. You're going to have people there that aren't astronomers. And this takes a lot of maintenance to keep track of one of these things. But this is straight solar projection. Solar projection. For totality, just look at it. You don't need anything to look at the sun during totality. You can stare at it if you like. You're in the shadow of the moon and you can't see the sun. You can see all this stuff around the sun, but you can't see the sun itself. You should look around to see the shadow of the moon, the 360 degrees horizon, and cloud formation or cloud dissipation happens during the totality. It might be nice to have a set of binoculars around because you can whoop them up and get details of the solar, of the corona here. You might be able to find a planet. I don't think you got a planet in this one. I got another one from Elson later where you could see Jupiter, I think. And that's nice. And you might want to look around the horizon to see how the shadow of the moon's moving. Do you need a telescope during totality? Probably not. There's not much to see because the field of view is probably not wide enough in the average telescope to see the corona, which is what you're going for during totality. There's some other weird things you got to look at, though, particularly just before second contact and just after third contact. Usually the source of light for us all is about half a degree across, and because of that, shadows are kind of fuzzy. But during approach of totality or just after totality, the source of light is very, very, very small. It's just a very bright thing, and you can't look at it, but it makes all the shadows very bright. It makes them so sharp that you can even cross your fingers back and forth like this person has done, and you can form pinholes. And those pinholes actually show you eclipsed suns right through the cloth. Here's a cute thing somebody did in Egypt. They punched holes in a piece of cardboard, and the holes were punched in the shape of a pharaoh's face. And you can see each of these little crescents here is actually the partially eclipsed sun, projecting a pinhole image on the ground there. So you get sharp shadows and pinhole effects that everybody should be watching. And where'd the shadow bands go? Something's out of order here. The moon shadow. This is going to take a while to play here. Josh, are there any questions? I'll talk and ask questions, answer questions at the same time. Check out this shadow coming across here. You should be watching this. Actually, the sun is probably all but the last little part eclipsed now, the last few seconds before totality. Look how the shadow is, you see it's still bright over here, but the shadow's moving straight across. Now you're in totality, and the shadow is above you, you're in the shadow, but all the way around you, you've got sun, bright horizon. Josh, are there any questions?
There aren't. It looked like for some reason your screen wasn't sharing for a while, although I kept seeing it, so.
Okay.
That's what happens when Adam's gone. But no other questions right now.
Okay.
It looks good.
After totality, which, get moving along here. Moving along, moving along, moving along. See, you can actually watch. Now, at this point in the eclipse, you got your choice. You can either be looking back up here for Bailey's beads and all that other stuff that I'll talk about in a minute, or you can look around and you can watch the shadow of the moon chasing off across the horizon. Particularly if you're up higher than everybody else, you can see you can actually see the shadow moving off across the plains. Another thing to look for are called shadow bands. These are very subtle. About 30 seconds to second contact, and then just shortly thereafter, third contact, you'll see these wavering lights like this. And if you want to take a picture of it, you've got to be ready to take a picture. What this guy did was he stuck some butcher paper up, and obviously he's got his camera pointed at it, and he can see the diffraction patterns of the light coming through. I don't have any pictures of it, but there's also other things like animal behavior and people behavior. In my first eclipse in Guatemala in 1991, everybody was, all the chickens and the dogs and everything, they said, well, it's nighttime, and they started crowing and stuff like that. The birds were flying around like they do just before dusk, things like that. People behavior was really weird in Guatemala. If you've ever been to a Central American market town on market day, you know that it's a very, very, very busy place. Everybody's out in the market having fun and everything else like that. Well, they all weren't. They had all run away to the cathedrals on either end of the Ramblas there, and they were praying, or they were at home. They were scared to be out in the market, even though it was big market day that day. So people do weird things during the eclipse, and the weather actually changes. More than a few stories of how the weather got clear all of a sudden, or the weather clouded up all of a sudden just when the moon shadow struck. So note all that stuff as you go along. Here are some of the things you need to watch for when you're going to watch an eclipse. There's the overall progress, and in this case it starts down here. You're starting with a full sun, and then here's first contact. Notice a little bit taken out. And then you got about an hour and 20 to 2 hours, depending on the geometry of the eclipse, of the sun gradually getting gobbled up a little bit more. Then you've got totality, and then gradually the moon moves away to the other side. See how that works? The moon has been moving across this whole time, moving across this way. By the way, this is a collage. The sun, and it's an artistic collage, the sun doesn't actually get real big right when totality comes. Okay, this central picture you see is even a collage in that the Bailey's beads, which are, where's my mouse? These Bailey's beads up here, the diamond ring effect, and the prominences are not generally there at exactly the same time. They actually take a few seconds apart. Now that I've mentioned them, Bailey's beads, if you know that there are mountains on the moon, and just before the sun is completely, totally eclipsed, and just before it reveals itself again, it's revealed again, the sun's brightest parts actually are shining through the mountains of the moon, and so you get little chunks of what are called Bailey's beads, bright spots along the edge of the moon. The diamond ring is one last big bright spot, and it's a big bright spot compared to all the other spots around there, and it looks like a diamond ring. You'll see better pictures of it later. And of course, prominences, now if you've been watching in hydrogen alpha, they've been there the whole time now. It's just that now you can look at them with your naked eyeballs. Okay, with about 5 seconds to go before totality, and for the first 5 seconds after totality, you can actually look at them with your eyeballs, and then the sun gets bright enough that you need to put your filters back in. Of course, you want to be looking at the corona. This corona picture is what you pretty much see. It is not what you would take a picture of. You can't get this picture. This is actually about 30-some pictures that have all been spliced together, composited by taking the bright, dimmer, 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 dimmer at all different exposure levels in order to get that. You can get earthshine when the glowing earth lights up the back side of the moon. It's kind of hard to see by naked eye, but you can get it in pictures if you were allowed to take pictures on your first eclipse. You can also see, you can't see many in my picture, stars and planets in it. Okay, this is all happening during totality. These beads and the diamond ring and the last only the very first part and the very last part. The prominences last pretty much the whole time, but they'll shift depending on which side the moon is covering and not covering. Then there's third contact. That's when the moon has been barely moved off. This is actually a third contact picture because you can see it's brighter over on this side than it was on that side. And fourth contact is when it's completely clear all the way up at the top. Learn that vocabulary. Everybody around you will be spouting it, and if you don't know it, you'll act like, oh, what is he talking about? Learn that vocabulary of what there is to look for. Here's some more detailed pictures of it, of first contact, last contact, fourth contact. Here's a partial phase, and here's a more detailed picture of some prominences, some Bailey's beads, and some of the diamond ring effect. Here's Alson's picture. I took this one. He took that one. I think this is a different eclipse. I'm not sure. Yeah, you can actually, they have different shapes of the corona, but you'll see that there's a planet there, and you can see that Alson got Earthshine in this. And we know this is Alson's because it's a really good picture. Not like, probably some of these are mine, which are poopy pictures generally. Anyway, this is what an eclipse looks like. This is the one in Egypt. This is what the sun is looking like right now as we're all down here. Now, because you don't have sound, you can't hear what's going on here. But they've just announced it's 30 seconds to go. I think he took his filter off a little early for 30 seconds. Everybody's yelling and screaming. They're all excited. They're first seeing the diamond ring and the Bailey's beads again. Prominences are starting to show. You notice that this picture does not show the full corona. That's because if it did, it would be overexposed in the center. Big diamond ring. Again, an exposure effect more than anything else. Notice how there's shadow up above, but all the way around the horizon, it's kind of light. Now this was a 4 or 5 minute eclipse. I forget exactly how long. The eclipse that we're looking for in 2017 is only 2 minutes and 40 seconds at the most, probably 2 minutes and 20 seconds for many of us out on the West Coast. Since you don't have sound, I'm gonna move this along here a little ways. Everybody, hurry up, hurry up, hurry up, everybody, hurry up, everybody, hurry up, hurry up, hurry up, hurry up, hurry up. And everybody gets all excited because at last it comes back, and they're all cheering, and you can't hear them. And we've got to do something to fix the sound here. Okay, folks, that's what an eclipse is like, and that's what you need to start looking for when you're going up planning in your eclipse. I hope that what I've done today is kind of showed you a little bit about the things to look for, the planning to do. I want everybody to know that if you don't have your hotel room yet, that's inconvenient. But seriously, I live in Southern California. I could actually decide about, I don't know, Sunday morning, right after church, I could walk out of church, jump in my car, and drive up to Oregon, see the solar eclipse, and be back at work by Monday morning, or by Tuesday morning. The eclipse is on Monday. And I could actually be awake for work. I mean, if I worked at all. So do take advantage of this eclipse. Now you'll notice that we didn't talk at all about taking pictures of the eclipse. And there's a reason for that. The old saw is that you, I'm going to stop screen sharing here, is that you don't take pictures at your first, eclipse. The reason you don't take pictures at your first eclipse is because it's just too exciting. And if you get wrapped up in taking pictures, you're liable to miss the eclipse, particularly in an eclipse that's only 2 minutes and 40 seconds. We are going to have some people come on later on to tell us about how to take eclipse during the pictures, or eclipse pictures. And that's about it. How long did we miss the screen sharing? What were you seeing instead during the screen sharing?
It looks like maybe we were seeing TAIC. I don't think it was for that long.
Okay. I'm sorry about that, guys. I don't know what happened because as far as I know, I was screen sharing the whole time. Okay. Any other questions? That's over in the other pile.
Not in Q&A and not in chat.
Okay.
That was awesome, though.
Okay.
Thank you for going through that.
Oh, okay. Well, I'm glad you appreciate it. I know I'm disappointed that I didn't talk about eclipse picture taking. I took a lot of those pictures, so obviously I can take some eclipse pictures. But I think that there are other people that might be better at explaining things. SOHO, Eric, the Solar and Heliosphere Observatory or something like that. It's a satellite out in space, and it takes pictures constantly of what the sun's corona is doing, what the sun is doing. And the reason it was significant was it can't see the inner corona where a lot of things are happening. The only time, because of that occulting disk that protects its instruments from being from too much solar power coming in. So that's what SOHO is. You can go to the SOHO website and you can download an image for what the sun corona looked like at any, just a whole backlog of all their pictures. So what's fun to do is to take your corona picture that you took during a solar eclipse and mesh it together with their corona picture and see how your corona picture matches theirs. Okay. Well, thank you, guys. That's the show for today. I think we've got all the questions, and that's good. It's we got it done in an hour, which is what we're supposed to do. I want to remind you that we're always looking for presenters. We have a few presentations lined up. Next week, what do we decided we didn't know what was next week.
Yeah, we do have something scheduled. I can't remember what it is for next week.
Okay.
Adam will send out an invite here in the next couple of days for us.
And on August 28th, Krister Strand will be talking about auto-guided or non-auto-guided images with his ASA mount. So they're unguided images with his ASA mount. So there'll be something for you to see with that. Okay? If there's nothing else, we're going to sign off for the day. Again, we are always looking for presenters. Please contact Adam on the Google Plus Astro Imaging channel page. If you've got a new setup that you'd like to talk about, a new technique that you're proud of that helps you get something better out of your images, any of those kinds of things, please get in touch with us. Be sure to continue to send in your submissions for images of the week. Until next week, this is Alex signing off on behalf of Adam and Josh and Eric and all the other guys that come, and all the ladies that show up. Thank you very much for being here tonight. Bye-bye.